distribution and testing of hypotheses. The name of the topic is concept and definitions relating to testing of hypothesis. So in this unit, we are going to discuss all the concept and all the definitions which are important for us in the testing of hypothesis. In fact, the whatever the test, parametric test or non-parametric test, all these tests are based upon these few definitions and concepts. So without wasting much time, let's discuss and understand these steps, these definitions. So a brief introduction to this unit. In statistics, hypothesis testing refers to analyzing an assumption about a population parameter. It is used to make an educated guess about an assumption using the statistic. With the use of sample data, hypothesis testing makes an assumption about how true the assumption is for the entire population. Any hypothetical statement we make may or may not be valid, and it is then our responsibility to provide evidence for its possibility. In this lecture, I will teach you important definitions relating to testing of hypothesis. So let's move further. So this is the content of this unit. So these definitions we are going to study thoroughly. So let's start with population and sample. So this definition these include parameter and statistic. So one change should there. This is just statistic, not statistics. So standard error of estimate, concept of null hypothesis and alternative hypothesis, critical region, type 1 and type 2 error, level of significance, one-sided and two-sided test of hypothesis, and p-value. So these are the contents of this unit. So let's understand this thoroughly. Now population and sample. So what is the population? It is the collection of all objects under study, or it is the totality of all objects under study. So in statistics, not necessarily the population means number of people. Okay, so it's not true. It can be any objects. It can be collection of objects. Okay, or it can be name of the cities or name of some living or non-living things. So population means it can be anything which comes under study. So group of each and every or collection of each and every object is population. Okay, so for example, my study is based on the average or uh, mileage given by the electronic vehicle, EV cars. Okay, so all the electronic vehicles, four wheelers, will come under that one. So if I'm talking about Pune, so all the four wheelers, electronic vehicles in Pune city will be my population, and I will take a few as a sample. That is our next definition. Sample, it is the representative part of the population. It possesses all the characteristics of the population. Just like when we visit a grocery shop. So what we do, we have to buy or purchase 1 quintal of grain, especially suppose wheat. Okay. So before making the decision, we just see the handful of it. हम थोड़ा बहुत जो है चेक करके देखते हैं हाथ में कि क्वालिटी कैसा है. So after that we decide. Okay, so after taking a handful of grains and then testing its quality or checking its quality, then after we do the decision. Okay, so this is nothing but the sample we take and then examine it and then take the decision. So sample is a representative part. If you like the sample, you will purchase the grain, otherwise not. So sample purchase all the characteristics of population. So the next definition is parameter and statistic. Okay, so this is very important definitions. So we must understand it. So in the earlier definition, we talk about the population, and then we talk about the sample. Okay. So whenever you think about population, then we are dealing with the parameter. Okay. And whenever you think about the sample, we will be dealing with the statistic. Okay. So let's try to understand what is the difference. So parameter is nothing but the statistical measure based on the entire population. Okay. Information is about the population and it's a population value or it's a truth. Whereas statistic is the statistical measure based on the sample observations only. Okay, so will take an example. Suppose uh, it contains 1,000. Suppose this is a survey regarding the opinion of people. Okay, so in a certain village or in a certain city, there are 1,000 people. Okay, so this is a population. Okay, so in response to certain question, so these are the objects, right? X1, X2, Xn up to X100, 1000. And then this is what population, and then I take a sample. Okay, so I take the sample of 100 people because I cannot, it's not possible for me to visit each and every. So I take the sample randomly. And then X1, X2, X100. Okay, so to all these people, I'm measuring a certain characteristic. Or suppose I'm measuring the age. Okay, so x1, x2, x100, x1000. These are the ages of all the 1000 people. So that is about the population. Okay, so this is about the population and this is about the sample. And suppose I'm taking the ages of only those who are in the sample, means 1 to 100. Then this is a sample observations. These are the population. So now where comes the parameter? Now whatever calculation I do based on all observations in the population are nothing but the parameters. So whatever calculation I do, a parameter. For example, suppose I get the population mean. Okay, so population mean, which is generated by capital this one. So what do you mean by this? Sum of all observations 1 to 1000 means I do addition of all the values here, 1000 values, and then divide by n means 1000. So this is parameter. So whatever statistical measure I get based on all observations in the population, that is known as the termed as a parameter. Similarly, now there are 100 people in this sample, and if I find arithmetic mean, which is called as the sample mean, means x bar, which is nothing but the addition of these 100 values in the sample. So this is called as a statistic. Okay, so this is called as statistic. Okay, so whenever I will talk about parameter, so population will come into picture, and whenever I'll talk about statistic, sample will come into picture. Okay, now one word is there, it is the truth. Parameter is the truth. Yes, it is the truth because when in the same example I will explain you, when I am talking about ages of 1000 people and I do calculate it, so it is the true value. Okay, suppose average age, whatever it may be, I take it now. Suppose average age in that 80, 28 years. So whenever I study each and every individual in this among this 1000, 1000, and whatever value I get, this is the true value, right? But when I take the samples randomly, so there can be any 100 observations, or this is sample one, or suppose another sample I took, that there can be any. So whatever the values I get, I'll get different means, isn't it? Because these values are taken randomly from this population. So these are not the true values. So these are all estimates. So these are all estimates. I hope you understand this concept. It is very important. So sample always give you estimate of any parameter value, whereas population value is the truth. I hope you understand now. Okay, so now let's move further. Hope you are clear with the population and sample, then parameter and statistic. Then these are the few symbolic representation of few important parameter and statistic. So this mean. So parameter, now one thing you must remember now, parameters are always related to population, whereas statistic is always relating to sample. Okay, so this is sample mean, this is population mean, this is denoted by mu symbol, and this is sample mean x bar. Whereas population proportion, capital P, it should be capital P, and this is P small p. Okay, sample proportion. Standard deviation sigma, this is small s. Correlation, it is rho and it is small r. Okay, and slope, it is beta and this is small b. So these are the various symbols so which are commonly used. Now standard error. Next important definition is standard error. So what is the standard error? So standard error is nothing but the standard deviation of the sampling distribution. Okay, so standard deviation of the sampling distribution. So it provides, what does it do? It provides the estimate that how far from the true value the estimated value is likely to be. So this is the important concept. So it measures or estimate, it provides an estimate how far from the true value estimated value is likely to be. So indirectly it gives us the difference between the true value and the estimated value. Okay. So some of the commonly used. So this is the standard error sigma upon root n. Okay, this is the formula. So commonly used standard deviations are like this, where SEX bar is standard error of mean, and sigma is standard deviation as seen earlier, and n is total number of sample elements. Similarly, for proportion, this is the standard error formula, and these are the P means population proportion, Q means 1 minus P, and then n is number of samples in the population. So now next very important definition of hypothesis. So what is a hypothesis? So hypothesis is a claim or assumption made about the population parameter. Okay. So in testing of hypothesis, we have to claim some. We always try to prove or disprove a statement. Okay. For example, average weight of average weight of children, or average weight of newborn babies in a particular hospital, or in a particular region. Okay, suppose Merghat. Merghat is a tribal area where newborns born with a very low weight, underweight. Okay, so uh, so this is, I have heard this. I'm not means I don't. Uh, I apologize if there is any mistake with this example. Just for your knowledge purpose, I'm taking giving this example. So suppose in a certain location there is a underweight students, underweight babies are born or 1 point below 2 kg. Okay, so this is a claim that in a location XYZ, newborn babies average weight is below 2 kg. Okay, so this is my hypothesis or this is my claim that average weight is less than 2 kg. Okay. So now this needs to be tested. Now this statement that average weight of newborn babies in a location, in a XYZ location is less than 2 kg. So this is a claim, right? So this needs to be tested. Okay. So for that, I need to take some sample, then do the measurement, and then from the sample, if it comes under certain criteria that it is less than, then I will accept it. Otherwise, I will reject it. Okay. So such kind of claims or hypothesis, such kind of claims or statements or any assertion is called as the hypothesis. Okay. So hypothesis is nothing but a claim. It is a claim or it is an assumption made about the population. So I am not talking about the sample. Please understand this. I am talking about the entire location. Okay. So whatever that location is, I'm talking about it. I'm not talking about any particular sample. So this claim is not for this. Okay. So this claim is not for this, but the entire population. So that's why it is called a hypothesis. Okay. So another example, I claim the mean CGPA of this class is this one, 7.5. Okay. So I'm talking about the entire class, not just few students. Okay. So what is the hypothesis then? Just sum up. It is a specific, testable prediction about what you expect to happen in your investigation. Okay. Sometimes written as if-then statements. So hypothesis is nothing but a statement or claim made about the population. That's it. Okay. So let's move on. So types of hypothesis. So there are two types of hypothesis. First one is null hypothesis, which is generated by H naught, and alternative hypothesis, which is a research hypothesis, and it is generated by H1. So statistical hypothesis of no difference. Okay, so it is the hypothesis. Null hypothesis is the hypothesis of no difference. This segment you have to remember. The no. So in null hypothesis, there will always be equal to sign. Suppose average weight of average weight of students in a particular class is 58 kg, right, or 52 kg. So if I'm saying average weight of students in a particular class is 52 kg, so equal to. So what do you mean by no difference? No difference means there will be equal to sign only. Okay. Whereas alternative hypothesis is that those hypotheses means which are against null hypothesis. So now any hypothesis against a null hypothesis is called as the alternative hypothesis. Now I take the same example. Now it is generated by H1, right? Now null hypothesis says it is equal to 52. Okay. Now there are three possibilities are there, that somebody say it is less than average weight of students is less than 52 kg, or somebody can say it is greater than 52 kg, and if one is not sure of, then he or she can also say that I don't know, that it's not 52. So all these three possibilities are against the null hypothesis. Okay, so these are all the three statements are called as the alternative hypothesis. So always remember, friends, alternative hypothesis will contain either greater than symbol, less than symbol, or not equal to symbol. Okay, whereas the null hypothesis will contain only equal to symbol. So that you have to take care of. Okay. Then these are few examples. Average marks of students in a class is 58 out of 100. So this is the null hypothesis, and these are nothing but the alternatives. Okay, so Similarly, this will complete. Now, let's come to the very important definition, critical region. Okay, so critical region. What do you mean by critical region? Now, in testing of hypothesis, entire number line. This is the number line on which this graph normal curve is placed. Okay, so this is 0. So this entire values on this number line are divided into two parts. Now, one part is such where the or null hypothesis is accepted, and the remaining portion where the our claim is rejected. Okay, in your simple language, if we say there is certain limits, these are the boundary values which we call it the critical values. So if any value lie in between these two, then it is safe, means our claim will be accepted. And if lies beyond it or it goes beyond it, this critical value, then it is rejected. Okay, so this is the concept. Now we understand it thoroughly. The testing of hypothesis, the set of all possible outcomes of a statistical test is divided into two regions. First one is the rejection region, which is nothing but the critical region, and acceptance region. Okay, so suppose this is now this is the normal curve you can see in front of the screen, and now here this is the critical value. Okay, so this is the critical value, whatever value it may be, suppose z minus z alpha by 2, and this is plus z alpha by 2. Okay, so the h naught will be accepted. Now this is the acceptance region. If the value lie between this range, within this range, then we accept h naught. But if any value lie in the shaded region, which is shaded with the red color, so if any test statistic lies in that range, then it will be rejected. तो जहाँ पे एक्सेप्टेंस रीजन है वो एरिया, वहाँ पे क्रिटिकल वैल्यूज के अंदर वो क्या रहेगा, एक्सेप्ट करेगा एच नॉट को, और बियॉन्ड दैट रेंज इट विल बी रिजेक्टेड. So now test can be one-sided or two-sided. Okay, so let's go through definition. Critical region or rejection region is a set of outcomes of a statistical test for which the null hypothesis is to be rejected. So this is the area I would like to show you again. So where I have, so see I'm shading it. So this is the area, this is the rejection area. So wherever it is shaded with red, so in this area, this is the rejection area called as the rejection area, and here h naught will be reject. So what is the decision for to be taken here? To reject h naught, but also reject. Now this is a two-sided test, that's why both sides you can see the shaded region. Otherwise, if it is a one-tailed test, you can see either in left side or you can see it on the right side of the normal curve or any curve. Okay, so there are further types test, we'll see it in the next slide. So the common decision for this set of values is reject. So critical region, to understand, it is a set of all values for which the decision is reject h naught. So this is the area where h naught is always rejected. Okay, or set of all values for which the decision is reject h naught. Okay, so that you have to remember. The next, critical region and critical value approach. So as I said, now situation can be anything, means test can be two-sided or one-sided. So if it is a two-sided test, I will explain you in the next slide. If the test is two-sided, then you can see there alternative. So whether the test is one-sided or two-sided, it will always depend on H1, and it will not depend on H0, because H0 always contains equal to sign, right? Equal to sign. And H1, it is the H1 which contains less than, greater than, or not equal to. Okay, so when you have not equal to symbol in the H1, you call it two-sided test. Okay, when you have less than or greater than symbol in the H1, just like this one and this one, you call it one-sided test. One-sided test. And this one is called as two-sided test. So it is the alternative hypothesis only on which the one-sided or two-sided test depends upon. Okay, so keep this in mind. Now, type 1 and type 2 errors. Okay, so this is very interesting. So in in testing of hypotheses, there are two types of errors possible. Okay, so consider this. So now I imagine a situation in front of you. Suppose H naught is true and it is rejected. H naught is true and suppose you accept. I write here. If H naught is true and you accept it, yes, it is a correct decision. And if H naught is false and it is rejected, again it is a correct decision, right? So error occurs in only two situations. So first situation is if H naught is true and it is rejected, then it is called as the type 1 error. Okay, H naught is true but it is rejected. It is called type 1 error. And when H naught is false but it is accepted, so this is false positive and this is true negative. Okay, so when H naught is false and it is accepted, false positive. Okay, so it is called as type 2 error. You have to remember that one. Let's summarize. So type 1 error is that one when you reject H naught when you reject a null hypothesis, when it is true, then it is type 1 error. It is also called as the producer's risk. So remember, sometimes it is asked in exam. You can be asked in Viva which type of error is producer risk and which type of error is consumer risk. Okay. So, and what is type 2 error? The reject H naught when it is true. Okay. So that is called as the consumer's risk. So let's move on next. Level of significance. Okay. So it is defined as the fixed probability of rejecting the null hypothesis. Whenever जैसे कि हम कोई भी एक्सपेरिमेंट परफॉर्म करते हैं तो वो एक्सपेरिमेंट के अंदर में हम हमेशा कुछ परसेंट को एज्यूम करके चलते हैं कि वो बियॉन्ड द स्कोप जाके यानी कि अंडर सर्टेन सिचुएशन आफ्टर प्रिपरेशन और taking care of everything, our results can be undesirable. Okay, so एक example में दूंगा. Suppose it is a match, cricket match between Afghanistan versus Australia. So what you say then? You say that 99% Australia will win, but still you assume there is a chance of winning Afghanistan, which is a new cricket team. Okay, or any other team you can take. You can take Bangladesh team, whichever team you take. This is just an example. So disclaimer, don't take it personally. So when we say 99% Australia will win, we are not saying 100% it will. So 1% you are keeping chance for the less competitive or that weak team. Okay. Sometimes we say 95%. Suppose it is a match between India and Australia or any other matches. I don't take the name of the countries. So any other team, you say, suppose. So what I want to explain you. So whenever all the situations are favorable, but still we assign some chance that you may get the surprising results. Okay, means you will get the worst. So it is a fixed probability of rejecting null hypothesis. So it is also called as the level of significance is also called as the probability of type 1 error. Okay, so type 1 error means reject H naught when it is true. So it can happen that you have worked very hard and still you failed the exam. It's just like that. Okay, so you continuously preparing for a particular exam and in spite of it you failed. So that is example of level of significance. Okay, जैसे कि हम बाजार जाते हैं, कुछ सब्जियां लाते हैं, पोटैटो सपोज, तो हम इतना इंस्पेक्शन करके वो पोटैटो सिलेक्ट करते हैं. We study it 360 degree and then we purchase it, even every potato or every vegetable, right? But still when you comes to home and then check it, cut it from the center, then you see that there is that is a rotten one, or that is not proper, that is you know uh, that is not the right one. Okay, so this is called as the level of significance. आपने इतना मेहनत करके वो खरीदी किया और उसके बाद भी वो खराब निकला, तो दैट इज व्हाट द लेवल ऑफ सिग्निफिकेंस इज. तो इन टेस्टिंग ऑफ हाइपोथेसिस हम हमेशा कुछ एरिया, कुछ प्रोपोर्शन फिक्स करते हैं इस तरह के एरर को होने के लिए, तो उसे हम लेवल ऑफ सिग्निफिकेंस, एंड लेवल ऑफ सिग्निफिकेंस इज नथिंग बट द प्रोबेबिलिटी ऑफ टाइप वन एरर रिजेक्टिंग इट नॉट व्हेन इट इज ट्रू. सब कुछ ठीक होने के बाद भी रिजेक्ट होना, ये जो चांस है, इसको लेवल ऑफ सिग्निफिकेंस कहते हैं. तो हाउ इट इज? So it is generally 1%, 5% or 10%. And if it is not mentioned at all, then by default, 5% should be taken and test should be carried out. So that is all about the level of significance. Hope you understand it properly. Now, one-sided and two-sided test, as I said, whether the test is one-sided or two-sided, totally depends upon the alternative hypothesis. Okay, because null hypothesis have both equal to sign. Only alternative uh, hypothesis have less than, greater than, not equal to symbol. So this decides the one-sided or two-sided test. If it is not equal to, then it is called as the two-tailed or two-sided test. Okay, and if it is less than symbol, then less than or greater than symbol, then it is a one-sided test, because it gives only one direction. Okay, this is the number line, right? And suppose you say not equal to, so what do you mean by that? Suppose this is 50, so not equal to 50, what do you mean by? So maybe it less than 50 or it is greater than 50. So both the directions are specified there. Okay, so what happens in less than is one-sided test? When you say that it is less than 50, so it gives us this direction, which is left side. Okay, so it is left side direction. And suppose you say that it is greater than 50, so it specifies right side. Okay, so that's why if less than are there, the alternative hypothesis, it is left tail test, and if greater than symbol is there, it is a right tail test. I hope you understand it properly. Let's move on next. So hypothesis tests. So hypothesis test is nothing but a process. Okay, so that is the sample statistic to take the claim. Okay, initially I had given you the claim. Suppose average weight of newborn babies in particular hospital for particular area is less than 2 kg. Okay, so this was the claim I made. So this is the alternative hypothesis, because in this case it is less than. So you have to be carefully read the statements. So this is H1. So what will null hypothesis say? Null hypothesis will say it is 2 kg only, no less, no greater, no more. So what is need to be tested in this question? What is the claim? So this is the claim, alternative hypothesis. This is the claim. So which says that it is less than 2 kg. You have to prove this one. Okay. So hypothesis test. So whenever you conduct a test, there is a process. Okay. So now this is the claim. To support this claim, you have to take the sample, right? And you have to get the values from the sample. Okay. Some values will be given, like population standard deviation. Okay. Sample size you have to decide. Again, when it is greater, if it is a large sample, then it should be lesser, greater or equal to 30, and if it is small sample, it should be less than 30. Okay, so then you do the calculation and then compare it, and then you take the conclusion. Okay, so all this process is a test of hypothesis test. This is called as the entire process is called as a testing of hypothesis. Steps for testing of hypothesis. So first of all, you state the null hypothesis H0 against alternative hypothesis. Then decide the level of significance. If it is not mentioned, by default it is 5%. By default. Then identify the model or distribution, like it is a Z test, G distribution, T test, T distribution, or F distribution. So you have to identify it. Then test statistics. Then write the formula. Okay. So just like it is x bar minus mu upon sigma upon root n is for single population mean. And then p value. Okay. So now p value will not be available, but we will be using criteria. Uh, you get the calculated value, and then from table, statistical table, you get the critical value. Okay. And you compare both. If calculated value is less than table value, this is nothing but z. Z alpha means what? Z table value. Okay. So if calculated value is less than table value, our decision is to accept H naught. And when the calculated value is greater than table value, what you do? You reject H naught. Accept H naught means reject H1. Similarly, reject H0 means accept H1. Okay. So this is the entire process. And then after you take the decision, this process, this one, and then you have to take the decision, just like I said. If calculated value is less than table value, accept H0, otherwise reject. And then you state the conclusion. So these are the steps of testing of hypothesis. So these are the general steps, the same steps, but in elaborated way we are written. And then p-value. So what is the p-value? P-value is also known as the probability value. What is called probability value? So it is defined as the probability of getting a result that is either the same or extreme than the actual observations. So this is the minimum value which is possible. Okay. So p-value is the least value which we will be comparing. The p-value is also known as the level of marginal significance, okay, within the hypothesis testing that represents the probability of occurrence of that given. If p-value is less than 0.05, you can reject a slot. Okay, so when it is less than 0.05, it is rejected. S naught is rejected. If it extends 0.05, then you accept H naught. Okay, so when you reject H naught, there is no enough evidence to accept H naught. Okay, so when it is less than 0.05, then it means if p value is less than 0.05, it means there is no enough evidences to accept H naught. That's why it is rejected. Okay, so we have covered all the topics in this unit, and thank you very much to all of you for patiently listening. Hope you understand everything. And if you didn't understand few concepts, then you have to go through the video again, okay, and read it, okay, or you can contact me. Thank you. Have a great day.